So the next class will be Tuesday next week?
Yes, the next one's Tuesday next week over these two sections. So in this unit, you've got 2 quizzes to take in my math lab. Okay, 2 sections of homework. It's very straightforward stuff. It's just there's several things to remember. Okay, so it's just trying to keep the amount of information on any particular test to a reasonable amount. So that's why there's 2 sections on this next one. All right, so the first one is section 8.3, which you got in front of you right now. And what we're going to deal with is 2 things in this section. If you remember, just before our last test, the very last thing, if you had that sheet, the very last thing we talked about in section 8.2 was I told you about the different types of quadrilaterals, parallelograms and squares and rectangles and things like that. So now we're going to just kind of take the next step in that, and we're going to talk about the perimeter and the area of polygons in the plane. Now, again, we're just going through this really quick, so we're just going to keep our discussion of perimeter and area just a few figures, just to get a little bit of experience. So the first thing, I don't like formulas if I can avoid a formula. So for perimeter, the perimeter, this is how we're going to remember it. The perimeter of anything is just the sum. Okay, the word sum means to add up. Okay, it's the total. It's the sum of the lengths of the sides of a figure. Okay, that's all you have to remember about perimeter. There's no formula. Some of you know formulas for perimeter just from your life before this class, but you don't have to remember any. So for instance, my example right here, I've got this trapezoid. We learned last time it's a trapezoid. And so what's the perimeter of this trapezoid? Well, the perimeter is just the sum of the sides. So tell me, the challenge on this problem is some extra information that is relevant to a future problem is given. What sides am I going to add up? What are the measures that I have to add up for this figure?
16.
Okay, 16, great. Yep. Another one? Perfect. This 12 inside, if you can see on your sheet, I think it printed okay, is dotted. That is a different dimension. That's just telling you the distance between those 2 bases. That is not a side of the trapezoid, so don't be fooled by that. And so now I'm just going to add up those 4 measures. And if anyone's done that quicker than me, then feel free to. 48. Thank you very much. Now, another thing to mention about perimeter. Perimeter is a linear measure. If this was big enough and I was just walking around the outside, perimeter is a 1-dimensional measurement. So I'm going to just put the units there are inches. Okay, that's what we got there. So 48 inches, just right there. So if you would do me the favor, exercise 1 right below it, I've given you a rectangle. Notice a rectangle has 4 sides, but only 2 of them are labeled. That's okay. You can know the other sides. Find the perimeter of that rectangle, please. Okay, even though they're not labeled, what is the measure of this side over here on the left? Yeah, it's 4 feet. I'm just going to label it right here. And then what's the measure of this side on the top? Yeah, don't forget those. I know that only 2 of the sides are labeled. The reason only 2 of the sides are labeled is because the other 2 have the same dimensions. So when I go to find the perimeter, which I'm just going to label P, I'm just going to start at the top and work my way around. So it doesn't matter what order you do this in. So 8 feet plus the next one is 4 feet, plus the bottom side is 8 feet. And then finally, the left side is 4 feet. And when we do that, I think we all would have gotten 24 feet, perfection. Anybody get something different that we need to talk about? All right, well, I just have one more perimeter problem just to make sure it sinks in, because I'm going to put a couple of these on the test that you're going to have a week from now, and I want you to mop up all those points. So find the perimeter of this trapezoid right here, please. Okay, so once again, the perimeter is all of those things on the outside. I'm not going to include this measurement inside. It's just telling me what the distance between the top and the bottom is. So I'm just going to start over on the left with 25 inches and then plus 5 inches, plus another 25, and then plus 19. And so that means the perimeter turns out to be perfect. Great job. Sounds like we've got some good feedback. Anybody struggling before I move on from the idea of perimeter? No formulas. Perimeter is just the distance around the outside. Done. All right, the next thing we're going to talk about in this section is, now we've talked about the distance around the outside of a polygon. The inside of the polygon, the region in there, when we measure that, that's called the area. So the area is the measure of the region inside the boundaries of a polygon. Kind of like when you put carpet down on your floor, that's what area is telling you, is how much, it's not just a one-dimensional measure now, it's two. We can go, in this room, we can go front and back, and we can go left and right. We have 2 degrees of freedom, 2 ways that we can move. And so the most basic, I'm going to try to present these area formulas to you in a way that you have the minimum amount to remember. Okay, but the bottom line is you have to remember this in a way that is best for you. So the most basic area here is of a parallelogram. The area of a parallelogram is the base of the parallelogram times the height, meaning the distance between the bases. So I'm just going to make a little note over here for you that h is the height, and the height is the distance between the bases. Just so that we are sure that we are picking the right measure when we're doing this. So my example 2, I've got a parallelogram right below. So we are going to find the area of this, and area is base times height, base times height. Just chant that to yourself a little bit. Hopefully it'll sink in. So if I'm looking at this parallelogram, I've got 3 measurements there, and 2 of them represent the base and the height. Which 2 do you think I'm going to use? The 25, if I use the 25 as the base, which you are right, that is a great thing. We're going to use the 25 as the base. Well, then the height then becomes this perpendicular measure from the bottom to the top between those bases, so 24. Now, every semester I get asked this question. It's a great question. You're probably thinking the same thing. Hey, could I use this side right here as the base? And the answer is yes, you could, but then that means that you have to be given the height. You would have to be given the distance between the left and the right. That would be the height. Okay, so the base that you pick is also dependent on what height is given to you. They are related. So in this case, I've got 25 times 24. I think it's a little early for mental mathematics. I think that's 600. Yes, all right, so that's 600. Now, when you label your area, you have to let everybody know that this is a 2-dimensional unit. And so the way that I'm going to label it, if I have centimeters times centimeters, I'm going to say that that is centimeters squared. You can write out, if you want, square centimeters. I don't mind. That is totally fine. But I'm going to use the first notation. All right, if you would flip over the page then, as some of you are doing, and go ahead and do the next exercise, find the area of that parallelogram. All right, the area of this is the base times the height. So which 2 dimensions here represent the base and the height? Yep, 13 is the base because I am given that perpendicular distance between those 2 sides. So yes, 13 inches times 6 inches. If I was going to use the 8 inches as the base, I would have to be given a different measurement. I'd have to be given the distance between the right and the left to use as the height. So 13 times 6, I believe that's 78. And what are the units that I'm going to use for area here? Perfect. Great job. I appreciate that. We doing okay? All right. Base times height, parallelogram. Now, if you remember before the test, the very last thing we filled in that little chart on the back of section 8.1. I told you there were other figures related to parallelograms, but they're just specific types of parallelograms. So for these other figures, you have nothing new to remember for the next couple. So a rectangle. This is not new. You're just filling in the blank so that I could give you something to do. A rectangle is a parallelogram with 90-degree angles. A rectangle is just a specific type of parallelogram. So because of that, the area of a parallelogram, now some books will use different letters, and you are welcome to, because I'm sure from middle school you've seen this before, but I'm just going to continue to keep things consistent because it's less to remember. So the area of a rectangle, again, is just base times height, or length times width if you prefer those, okay, if you draw back on some previous memory. So let me put that, or length times width, one of those two. I'm just going to keep using base times height because it's just a parallelogram. So if you would please just go ahead and do exercise 4, find the area of that rectangle. So the area of a rectangle, it's just a parallelogram. So base times height, or length times width if you prefer. So 8 feet times 4 feet. So 8 times 4 is 32. That's not a big deal. And then what are the units of my area? Perfect. Feet squared or square feet, whatever you want to do. Now, the reason I gave exercise 5 is not just to torture you with another example of a parallelogram. This time it's a square. But what I wanted to make you aware of is whenever you're finding the area or whenever you're finding the perimeter, your units have to be consistent. And notice on this square right here, I'm given feet on the bottom, I'm given yards on the right side. So you have to pick. Are you going to use feet? Are you going to use yards? So that we're just all doing the same thing, let's just all use feet. So your first step is you need to convert this right side from 2 yards into feet. If you need to set up your unit ratio like we learned in the last section, remember that in 1 yard there are 3 feet. So I'm going to give you a moment to sort through that. So you got to convert that right side into feet, and then you got to find the area. 2 things. Okay, just for your recollection, now I know some of you, probably all of you, can do this mentally, but just in case you can't, 2 yards, I'm going to use my unit conversion like we learned in the last chapter. And there are 3 feet in 1 yard. That's a pretty small number. It's a pretty common conversion. So you probably could have done this without the unit conversion. 2 times 3 is 6 feet. So this side over here that's labeled 2 yards, it's also 6 feet. Those mean the exact same thing. So now I'm ready to find the area because now I have measurements that are consistent. So each side is 6 feet. So base times height or length times width. Again, I'm just trying to, if you know another formula for this, that is great. I'm just trying to minimize the amount of stuff you have to remember because I want you to be able to excel on this test. So 6 times 6 is 36, and then I'm hoping you wrote down units, feet squared. Anybody get anything different that we need to talk about on that problem? don't hold back in case you have anything. There's no reason not to bring up your questions. Okay, so again, trying to keep things as easy to remember as possible. The way that I always remember the area of a triangle, okay, remember triangle has 3 sides and 3 angles. What the prefix tri means. So a triangle is half a parallelogram. So on this drawing down here, this purple triangle that's on your sheet, what I'm just going to do is if I could copy and paste, what I'm going to do is I'm going to copy and paste this triangle upside down. So I'm going to take that same triangle and I'm just going to do a copy of it like this. And notice when I copy and paste that triangle and glue them together, I have a parallelogram. A triangle is just half a parallelogram. So because of that, because a triangle is half a parallelogram, the area formula is given by this. Well, I know that the area of a parallelogram is base times height, and since a triangle is half of that, I'm just going to throw a half or a 0.5 out in front. So a triangle is half a parallelogram. And I can see that by this drawing. Hopefully that was helpful for me to use my poor artistic ability to show you that when I copied that triangle, I just made a parallelogram right there. And so I'm going to go ahead and find the area of the triangle, or you know what, I am going to have you do it. I didn't give 2 examples right here. So all that's required here is you to be able to multiply by a half. So go ahead and find the area of the triangle in exercise 6. Okay, so we're finding the area of this purple triangle right here. This shadow was just for illustration purposes only. So the area of this is going to be 1/2 because the triangle is half of a parallelogram times the base, which is 3 inches in this case, times the height, which is 1 inch in this case. And I don't care, decimals are fantastic when we're doing this. So 1 times 3 is 3, 3 times 0.5 is 1.5, and it's going to be 1.5 inches squared. Again, did anybody get something different? I know I threw a fraction in there, and that sometimes freaks us out a little bit. Okay, well then we're almost done with our polygons. Just got a couple more things to talk about right here. So the other type of quadrilateral that we talked about in that chart before we had the test is what's called a trapezoid. A trapezoid only has 1 set of parallel sides, unlike a parallelogram where both pairs of sides are parallel. So in my example 3, my yellow figure there, that's just a trapezoid. It's pretty standard looking trapezoid. The top and the bottom are the sides that are the same distance apart. The left and the right, you can see they're angled toward each other. So a trapezoid, again, I'm just trying to find a way to keep this in my memory. For a parallelogram, we've been doing base times height, base times height, base times height. But the problem with the trapezoid is it can't be base times height because these bases have different lengths. So this is the way that I remember, this is the way that when I learned this long ago that I decided to remember it, that the area of a trapezoid is going to be like this. Since the bases are different lengths, I can't just say base times height. So what I'm going to say is it's the average of the bases times the height. Just still trying to follow that pattern of average of the bases. Now, when I use the word average there, if you take 2 tests in my class and I ask you what your average is, what do you do with those 2 tests? Add them up, divide by 2. Yep. So this, if you remember what an average is, average of the bases times height, then you know everything you need to do. Here's the technical formula for a trapezoid. Okay, but it's just average of the bases times the height. The average of the bases, you're going to take base 1 plus base 2, top plus bottom, or left plus right, whatever the bases are, divided by 2 times the height. Okay. So if you look in the book, that's the formula that you'll see. But the way that I'm hoping that helps you remember that a little bit is to remember it as the average of the bases times the height. So I'm going to work this problem. This is my example. Then I've got one that you're going to go ahead and do. So for the trapezoid there, that's yellow. We're going to find the area of that by doing the average of the bases times the height. So here we go. So the parallel sides are the ones that I'm going to call the bases. So that's 19 inches plus 5 inches. Those are the bases. Divided by 2, that's going to give me the average. Now the height here is given to me as 2 feet. Again, I just gave this example as another one to remind you that our units have to all be the same. So I've got to convert that 2 feet into inches. Again, that's probably something most of you can do mentally, but just in case you can't, I'm going to come over here, use my unit conversions. In 1 foot, there is 12 inches. Okay, you still have that chart. It's on one of the packets that I gave you. So when you're doing your homework, I think anytime you need it, my math lab will give you the conversion. But just in case, just make sure you have those charts. If you need another copy, I have some extra ones in my office. No problem. And 2 times 12 is 24 inches. So my height for this trapezoid is 24 inches. So 19 plus 5, that also is 24 divided by 2. That means the average of the bases is 12 inches times 24 inches. And 12 times 24 is something. 288, you said? Perfect. Thank you for your help. 288 inches squared. Yes, that was a little more complicated than the others. Is there a question, comment, concern about finding the area of a trapezoid? Average of the bases times the height. So exercise 7, you have your own trapezoid to go ahead and find the area of. All right, once again, the area of this trapezoid is going to be the average of the bases times the height. So which 2 sides are the bases of this trapezoid? Yeah, the 16 and the 6. The 13s on the end, those are not parallel. Those are getting closer to each other. So those would not be the bases. So it's going to be the 16 plus the 6 divided by 2. That's the average of the bases. And then the height, which is the difference, or excuse me, the distance between those 2 bases is 12. All my units are in inches. I had no conversions that I needed to do on this particular problem. So in the parentheses, 16 plus 6, that's 22, divided by 2 is 11 inches. And then the height is 12 inches. And when we do that, what do we end up with? Perfection. So exercise 8 is kind of a simple application of area. So I'm going to give you a moment to chew on this. It says the cost to install new carpet is $8.19 per square foot. If you want to install carpet in a room that measures 25 feet by 13 feet, I'm assuming that it's a rectangle. I didn't say that, but I'm assuming somebody didn't build a trapezoidal room. So if you want to install carpet in a room that's 25 feet by 13 feet, what would the total cost be? So there's two steps to that problem. If you don't know what the second step is, you can at least do the first step, which is to calculate the area of that room. All right, there's two steps to a problem like this. When you go through and do your homework, you're going to see problems that are like this. On the test, I'll probably have one, maybe two that are like this. So the first step is, okay, if my cost is in terms of square feet, that's an area concept. So I need to calculate the area of this room. So the area of the room is just going to be 25 feet times 13 feet, base times height or length times width of this rectangular room. And when I do that, 25 times 13, perfect, thank you. So it's 325 feet squared. So that's just what we've been talking about. Here's the new step. How do I calculate the cost then? Yeah, each of these square feet, I've got 325 of them. Each of those 325 square feet is going to cost me $8.19. So I take that 325 feet squared and I multiply it by $8.19. And that's going to come up with what? Did I hear you right? $2,661.75. Perfect. Great job. Any questions about a problem like that? All right. Well, that for our straight-sided figures is perimeter and area. There's one other figure that we're going to talk about the perimeter and area of after we take a brief digression to talk about another concept related to triangles. Okay, you probably have seen this if you've taken any sort of algebra class. This comes up there too. It's called the Pythagorean Theorem. And what the Pythagorean Theorem says is that there is a cool little relationship between the three sides of a right triangle. Okay, so for a Pythagorean theorem, you've got to have a right triangle. So if you have a right triangle, so I'm going to draw one best that I can. We're going to assume that this is a right triangle. So I'm just going to, it's going to be standing up like this. Not too bad. I'm going to let you know that that's a right angle. The traditional labels for the sides, you could really use any letters, but the most commonly used ones, for whatever reason, I don't know why, A, B, and C. So if you have a right triangle, then the relationship between those three sides goes as follows. First, sides A and B, these are the sides that are right around the right angle. These are called the legs. So this would be leg A and leg B. And then this longer side that's on the opposite side of the right angle, that's called the hypotenuse. So if you have a right triangle, then the sides, the relationship is given like this. If you take A and you square it, then you add B and you square it, then what you get is C. You square it. So Pythagoras, the Greek mathematician from long, long ago, he didn't necessarily invent the Pythagorean theorem. The Babylonians used it a lot, and we talked about the Egyptians and their great use of geometry. But what Pythagoras did is he codified it and wrote it down and wrote it down and also proved that it was true. So you don't have to know any of this. It's just fun math history. We've got some time. So back in the day, okay, if you were learning math back in the day, they didn't have all the cool symbols that we have and letters. So what you would have said is, if you wanted to say that you were multiplying a number by itself, if you were squaring a number, then what you would have done is you would have drawn a square. You would have drawn the picture. So what Pythagoras was saying, and what the Pythagorean theorem says, and he proved it using geometry, that is why it's named after him, is he said if you take the square that's this area right here and plus the square that's this area, then it's going to equal the square of this area. So you can see it's much more bulky to be able to talk about multiplying things together back when you didn't have like fun multiplication symbols and things like that. What we have here is a product, like the way we can write down math and numbers and equations and things is the product of thousands of years of people thinking about this and it developing, and it's gone around the world. And our system is actually a merging of the Hindu system from India and the Arabic system that was in the Middle East. And then it got used, and a lot of Italian mathematicians borrowed concepts from both and merged it together, and that's why we have our symbols. So this is how Pythagoras would have thought about this problem. He wouldn't have written it like we write it, with A with a little 2 on it plus B with a little 2. He would have drawn that. And if you ever look it up, history of math, it's a fun little thing. You might not be interested at all. That's okay. I majored in math, so it makes me happy. So it's bottom line, a squared plus b squared is c squared. It allows us to find the sides. So here we go. Here's my right triangle. I'm going to do this example. So what we're going to do is we're going to identify what sides the legs are and what side the hypotenuse is, and we're going to plug and chug at that point. So on my triangle right here, which sides are the legs? Yeah, I'm just going to underline them. The 15 and the 8 are the legs. Those are the ones I'm going to square and add together. So I'm going to write, it doesn't matter what order, 15 squared plus 8 squared. So you always take your legs and square them and add them together. And then that's always going to be equal to, on the other side, the hypotenuse squared. And in this case, that's the one we don't know. So I'm just going to write the letter C. You can use whatever letter you want. Use the letter C. At this point, just becomes kind of a calculator problem. 15 squared, 15 times 15 is 225. 8 squared, 8 times 8 is 64. And that's equal to C squared. 225 plus 64, I think that's 289, but it's still early. You should always check. And then the last thing, okay, so I know now that C squared is 289. What button on my calculator am I now going to hit in order to figure out what just plain old C is going to be? Yeah, I'm going to hit the square root button. So if you don't know, like I don't know how much experience you have using your calculator, if you're comfortable with it, if you got a brand new one, if you don't know how to square something and do the square root on your calculator, just stop by after class. It'll take us 4 seconds literally to find the button to be able to do that. So I'm going to just do that on this calculator right here. So I've got 289. My square root button is right here. They're in different places. Oh, I didn't even do anything there. There we go. That's better. 289, and then I'm gonna hit the square root button, and that turns out to be 17. So C is gonna be 17, and my units are yards, so I'm just gonna throw the yard symbol on the end of that. All right, your example, you don't know one of the legs, but the process is super similar, so see how much of that you can do, and then we'll check your work and correct any mistakes that we have to do. All right, so on this particular problem, there's an additional step to get to my value, just because this time it's not the hypotenuse I don't know, it's one of the legs that I don't know on this particular problem. I wanted to give you an example of each of them because that's the two things you'll see when you're doing your homework. So what are my two values of my legs in this particular problem? C and B. Okay, so great. I'm glad you mentioned this. I know in the previous problem we knew both of those values and we called them legs, but the legs are always the ones that meet at that right angle. Okay, so the 10 is across. The 10 is still the hypotenuse. But this case, it is different because we know the hypotenuse in this one. What we don't know is one of the legs in this one. So the legs are always going to be the things that emanate from the right angle right there. So in this, the way I'm going to set it up is I'm going to take my 8 and I'm going to square my 8, then plus my a, and I'm going to square my a. So the reason this problem's a little bit different is the thing that I don't know is on the other side of the equation. On the other side, my hypotenuse is 10 squared. So again, it's a calculator problem from here, but we've got to approach it a little different. On the previous problem that we did, since both of the values that we knew, both of the legs were on the same side, I was able to just square them and add them up and then take the square root. On this one, I have a little bit of a different approach. So first thing I'm going to square just like I did. So I've got 64 plus the a squared, and 10 squared is 100. But on this one, instead of adding the two values together because they're on the same side, what do I have to do with this one before I can take the square root? Yeah, I got to take that 64 and bring it to the other side. I've got to subtract it. So a squared is equal to 100 minus 64, which looks like it's going to be 36. And then on your calculator, if you need to, you put 36 in, you hit that square root button, and you're going to get that the value of a this time is 6 inches. So I'm glad that got brought up. Whenever you're doing one of these problems, the legs are always going to be in the same position, whether you know their values or not. They're always going to be the sides around the right angle. Those are the two, that's the only two types of problem you can see as far as the Pythagorean theorem. You either don't know the hypotenuse or you don't know one of the legs. Here's the setup if you don't know the hypotenuse. Here's the setup if you don't know one of the legs. All right, flipping to the last page, just a few more problems. The last thing that we are going to talk about is a circle. We haven't seen or talked about circles, but circles are a figure in the plane. They're two-dimensional. And so the definition of a circle is all the points in the plane the same distance from a reference point called the center. So a circle is all the points in the plane that are the same distance from a reference point. So here's my reference point. I'm just going to draw a little circle. Here's my reference point. And now, if I can, always in debate. Oh, that's not too bad. That almost looks like a circle. Great. So there's my circle with my center. So it's all the points that are the same distance from that central point. So here's my first bit of trivia. You may or may not know this. If you don't, that's okay. I'm not assuming you do. Does anyone know the name of this distance from the center out to the side of a circle? It's called the radius. Yep. Right. We can also draw the line that goes all the way from one side of the circle to the other side of the circle through the center. Does anyone know what that's called? You're a step ahead. Circumference is going to be something slightly different. From one side of the circle to the other through the center, that is called the diameter. And then the last little bit of trivia, the diameter and the radius, you have to know. This last one, this is just optional trivia, just you can impress your friends and family members with. The diameter is actually a specific kind of what's called a chord. You can draw a line from any point on the circle to any other point, and it's called a chord. And so the diameter is the specific chord that goes through the center of a circle. Like I said, you don't have to know what a chord is. It's just fun extra knowledge. So the circumference, as was already mentioned, the circumference is the fancy math word for the perimeter of a circle. The circumference is just the distance around the outside of the circle. So the circumference is given like this. Now we're going to encounter a new number. Okay, we'll talk about what it is. So just bear with me for just a moment. The circumference is 2 times this number that is unique to circles called pi times the radius. So pi is a number that's called an irrational number. You don't have to know that. I'm just trying to give you a little exposition here. An irrational number is a decimal that will never repeat and it never ends. So if you're interested in, you can go on to Google and you can put in digits of pi and you can see people that have calculated pi out to millions of digits, and you can read through if you're looking for some way to fall asleep. Okay, you can read through some of the digits and you'll see that there's never any pattern that repeats. Actually, there's a couple of interesting things in the, like about 1,000 digits in, you get, I think there's like 5 9s in a row. So it's kind of just a weird little bit of trivia about pi. You don't need to know that. I'm just excited because I'm a math geek. Anyway, so it's kind of hard for us to write down a number that never ends. And so we use an approximation. So the approximation that we are going to use in here, you can either use the pi key on your calculator if you have one. This particular calculator, this Texas Instruments, has a pi key right there. That's going to give you a little more detail and it's a little easier to type in. If you don't have a pi key on your calculator, use 3.1415. I will tell you that on the test. Okay, on the test, my instructions to you will be either to use the pi key or use 3.1415 so that you don't get too much round off error. Okay, follow whatever instructions my math lab gives you. Okay, and the same thing. So that's going to be our approximation for pi when we find the circumference. So we'll come back in a minute and talk about the area, but I'm going to go down to example 5. In example 5, we're going to find the circumference of this circle. So the circumference of this circle is going to be the following. It's going to be 2 times pi. I'll use the pi key in my calculator, but when you're practicing, if you don't have one, use 3.14. And then what's the radius of this circle right here? 6 centimeters. Okay, notice on the problem I'm going to have you do, you're given the diameter. What are you going to do to the diameter in order to get the radius? Divide it by 2. Right, the diameter is just 2 radii glued together. So in this case, we've got 6 centimeters. Once you plug the appropriate number in the appropriate place, the rest of this just becomes a calculator problem. So I'm going to take, let's clear this. Where's my clear button on this calculator? Just going to hit that again. So I'm going to hit 2 times the pi button. There's my pi times 6. And that's going to be equal. And I'm going to round to the hundredths place. I'm going to go 2 decimal places to round. Again, I will let you know to do that on the test. Follow your My Math Lab instructions. So that's 37 point. My thousandths place is a 9. That tells me to round up. So when I round up this other 9, that makes the 69 into a 70. So 37.70 centimeters is going to be the result that we look for there. So I would like you to do the same thing on the next problem down. I'd like you to find the circumference, round to the hundredth place. And again, if you have a pi key on your calculator, use it. If not, use 3.1415. Our answers might be a touch different, but should be close. So the circumference is 2 times pi times the radius. Well, if my diameter of this is 8 yards, what's my radius going to be? Perfect. Great job. I appreciate your help. And so I just go ahead and multiply those things together. So here's my calculator. You've probably already done this, but let's just verify. 2 times pi times 4 turns out to be 25.1327. I recommended that we round to the 100th, so 25.13 yards. Anybody get something different that we need to talk about and see what's going on? All right, well then the other thing, this is the last bit of new knowledge for the day. Finally, the area of the circle. So I want to be able to find the inside region, the two-dimensional area. So the area of a circle is this. It's going to be pi times this times the radius squared. So pi times the radius squared. So whatever your radius is, you're going to square it, then you're going to multiply it by that irrational number pi, and then that'll be your answer. We're going to round to the 100th. Once you've written that down, I'm going to go ahead and do example 5. I'm going to find the area of this circle that we already found the circumference on. So that's going to be pi times 6 centimeters squared. So again, here's my calculator, my good friend. So 6 squared, 6 times 6 is 36, times my pi key. And I'm just going to round that to the 100th place. So that's 113.097. So again, my 10th place is 9. So the 100th place is a 7. That tells me to round the 9 up. So that what happens is that becomes 113.10. Yes, perfect. Centimeters squared. So I'll give you a few moments. Go ahead and find the area of that other circle. And then we just got a couple problems left to finish out our day. That's just going to combine some of the things together. Yes? I'm sorry? Our units are squared. Yes, because it's area, so the centimeters are going to be squared. Now that square on the centimeters does not apply to the number. We've already done all the calculating with the number. Great question. Right, the area of this circle, again, is just going to be pi times the radius squared. So in this case, when we look over here, you already told me in the previous problem that the radius is going to be 4 yards. So we've got 4 yards that we're squaring. So that is going to be 16 times pi. And in my calculator, when I do 16 times pi, and we're going to round to the 100th, I've got 50.265. So the 6 is in the 100th place. The 5 is right behind it. That tells me to round up to 50.27 yards squared. All right, so the last couple problems are just a way that the book and myself are going to get kind of two for one. So exercise 11. You're going to talk me through this before you go ahead and do it. What 2 figures are involved in exercise 11? What do you see? Okay, the bigger figure is a parallelogram for sure. And then what else? A circle. Okay. So what I've got here is I have a parallelogram, and then I've come and punched a hole in the circle. And so the question is, find the area of the blue area here, the shaded area. So what am I going to do? I'm going to find the area of the parallelogram. I'm going to find the area of the circle. What am I going to do with those areas to find the shaded part? I'm going to subtract them. Yeah, I've punched a hole. This is no longer blue, so it's gone. So I'm going to find the area of the parallelogram, and then I'm going to subtract the area of the circle. So I'm going to give you a couple minutes to figure out as much of that as you can. Okay, you can find the area of the parallelogram. There are the dimensions because notice this circle goes from the top to the bottom. So that can give you the height of the parallelogram, just as a little hint. Mhm. Mhm. All right, so the first one is the parallelogram. This might be the one that you might have had a little trouble. I'm going to abbreviate. So the area of the parallelogram. What's the area of a parallelogram? We said earlier it's the base times height. Great. So the base, I think, is clearly apparent. The base is 10 feet of this. The height, this might have been something that you didn't quite observe. What is going to, I'm just going to use my pink marker, pink pen here. What's the height? What's the distance from the top to the bottom of this parallelogram? Yeah, it's the same thing as the diameter of the circle. So it's 4. Okay, so that's one of the challenges of this is observing that. And if you didn't, that's okay. You just learned and you're going to get to apply that learning to the very next problem. So the area of the parallelogram, 10 times 4 is 40 feet squared. Then the next thing we're going to do is we're going to find the area of the circle. Well, the area of the circle is pi times r squared. So pi times 2 feet squared. So I put that into my calculator. I've got pi times 4 because 2 squared is 4. So 4 times pi turns out to be 12.57 feet squared. So if we picture this as like a piece of carpet or a piece of wood or something like that, I've got the bigger figure. Now I have a hole in it and I want to figure out what remains. That's why I'm just going to subtract these two things. Okay, because I have the whole figure and I've taken a part away. So the shaded area, I'm just going to write the word shaded right here. So this will be my answer. The area of the shaded part is 40 feet squared minus the 12.57. So that turns out to be something. 27.43. Beautiful. Feet squared. Awesome. Well, just because I wanted us to end on a high note, and I know sometimes that's a struggle figuring out that height of that parallelogram, I want everybody to leave with confidence. So exercise 12 is very similar. I've just changed the figure very slightly. So go ahead and figure out the shaded part. What remains? What is the area of that gold part that's on the outside of the circle? Okay, give you a couple minutes, and then we'll finish up, and then I'll give back your tests. All right, on this problem, the two figures I have, instead of a parallelogram in a circle, I got a square in a circle. Okay, so the area, first I'm going to start with the area of the square. Well, what are the length and the width, or what's the base and the height of the square here? What's the dimension? Yep, and each is going to be 6. It's just the diameter of the circle. So it's going to be 6 feet by 6 feet. So the area of the square, the bigger figure, is 36 feet squared. Okay, so we're on our way. Now I'm going to find the area of the circle. So we've had this hole punched in the middle of the square. So the area of the circle is pi times r squared. So 3 feet squared times pi. So that is 9 times pi. So here's my calculator. And so 9 times pi is going to turn out to be 28.27. And then what am I going to do with those two dimensions in order to figure out the gold part? Yep, again, we're going to subtract. And so we've got 36 minus 28.27, and that turns out to be what? Before I shut off the recording and move on, does anyone have any questions? Is anything, you get something different that we need to talk about? All right, well, I'm trusting your judgment.